All right, I think we are live. Welcome back, everyone. I hope that you enjoyed our last session about health and equity in the built environment, which was moderated by Catherine Cruz. My name is Bettina Maynard. I am the president and CEO of AHL, and I am a longtime member of the AIA Honolulu. This session is about Carboncure. It's titled Cracking Concrete's Enormous Emissions Problem. But before we go any further, I was asked to give you some quick instructions to ensure that we all get the best out of this virtual session here today. So first, you will see at the bottom of your screen a Q&A box that you can ask any questions with, and it is a quick way to the panelists and to our staff. If you are experiencing any technical issues, please contact the tech support at the number on the lower left there. And then lastly, this session qualifies for AIA learning units, and AIA Honolulu, of course, is a registered provider. All attending AIA Honolulu members will have the credits applied to their online transcripts within 10 business days. If you are not an AIA Honolulu member and you need proof of participation, you can contact the AIA office for a session certificate. Okay, the next slide should be a reminder on where on our schedule we are. We are session number 2, and there are 2 exciting other sessions following this one. So without much further ado, I would like to jump right into our topic. And I want to start with pointing out that it is a particular pleasure to be here today and moderate this panel of visionaries. It was several years ago when I first met Robert Neven through Aki Marceau, who was with Elemental Accelerator at the time. And what I learned about carbon sequestering concrete in that conversation fueled my fire. And it gave all of us one thing that was so brilliantly easy and straightforward that I could not see how it could possibly be argued with. And more on that later. But before we jump into our panel presentations and the discussion, let me frame the issue. The numbers that I'm referring to now are provided by AIA's Architecture 2030. Buildings generate nearly 40% of annual greenhouse gas emissions. Of those total emissions, building operations are responsible for about 28% annually, while building materials and construction, typically referred to as embodied carbon, are responsible for the remaining 11%. Global building floor area is expected to double by 2060. This will be the largest wave of urban growth in human history. It means 2.4 trillion square feet of new floor area will be added to the global building stock. This is the equivalent of adding an entire New York City to the world every month for 40 years. And without wanting to be overly dramatic, but to save our planet, we need to achieve zero emissions from new construction. And we need to insist on energy efficient buildings that use no fossil fuels, that are 100% powered by renewable energy, and that reduce the carbon footprint of the entire construction process. The new construction that is projected to take place from now to 2040 highlights the critical role embodied carbon plays. Because unlike operational carbon emissions, which can be reduced over time with building energy upgrades and the use of renewable energy, embodied carbon emissions are locked in place as soon as the building is built. So it is crucial that we get a handle on embodied carbon now if we hope to achieve zero emissions by 2040. So to achieve this, the AIA suggests to adopt 3 principles: reuse, including renovating existing buildings using recycled materials in new construction and designing for deconstruction; reduce, including material optimization and the specification of low to zero carbon materials; and sequester. It includes the design of carbon sequestering sites and the use of carbon sequestering materials. Just 3 materials are responsible for 23% of global emissions in any industry: concrete, steel, and aluminum. And most of those are used in the built environment. So there is an incredible opportunity for embodied carbon reduction in these high impact materials through policy, design, material selection, and specification. So with that, I am handing the floor to our panel. I cannot wait to hear about the project. Actually, I'm not totally handing it over because first I want to introduce them. Please help me welcome Robert Navin with Carboncure. Robert is the founder and chief executive officer of Carboncure Technologies, the global leader in carbon dioxide removal technologies for the concrete industry. Rob has the simple goal of making concrete sustainability both profitable and easy. Under his direction, Carboncure and its partners are achieving their mission to reduce 500 million tons of CO2 emissions annually by 2030. Next is Steve Teves. Steve, with AIA, is a principal at Design Partners, began his architectural career at DPI 19 years ago after graduating from Honolulu Community College's drafting program and the University of Hawaii's School of Architecture. And while in school, he worked in the construction industry, both in the office and on the field, which contributed to his understanding of construction means and methods. Then we have Alana Kobayashi Pakala. With nearly 2 decades of Hawaii real estate development and investment experience, Alana is a partner and chief operating officer at the Kobayashi Group. She is responsible for managing and overseeing all real estate development projects from market opportunity through entitlements, design, sales and marketing, construction, and post-completion oversight. And we have Steve Baldridge. Steve is the president and founder of BASE, a structural engineering firm headquartered in Honolulu with offices in Guam, Chicago, Florida, and India. He leads their pursuit of innovation and practical approaches to make buildings stronger, safer, and more efficient. And Michael Young, in his 12-year tenure at Albert Kobayashi, Michael rose from project engineer to pre-construction manager and is now serving as the president and CEO. It's a position he earned in 2020. He holds a bachelor's degree from the Massachusetts Institute of Technology and a master's degree from Stanford. Truly a spectacular panel. We will now hear each of our panelists give a brief intro and hear about one project, just an example to all of us here in Hawaii. So Rob, take it away, please.
My pleasure. Thank you so much, Bettina. And I have the grave misfortune of having to follow Bettina and her remarks. So thank you so much for that. And it's absolutely such a pleasure to be here today, albeit virtually. I'm beaming in from Vancouver, British Columbia. So I'd like to provide a bit more information about low carbon concrete and how Carboncure is helping to reduce the embodied CO2 of new construction. Let me begin with a question. And as Bettina had mentioned before, is that embodied carbon is expected to account for nearly 50% of the carbon footprint of new construction. And concrete, being by far the most dominant construction material worldwide, is going to be a key component in that solution to be able to decarbonize construction and especially embodied carbon emissions. So to provide a bit more detail on, what is it that we're talking about between embodied and operational? Operational emissions are what we normally think about when we decarbonize buildings. So high efficient buildings means using less energy, means using and designing and building the right envelope to be energy efficient. And that's where we've made some drastic gains in making more efficient buildings that are then releasing less CO2 emissions. But the other half of the equation is the embodied CO2 emissions, which are those emissions that are released from the manufacturing of building materials in the construction phase. And these CO2 emissions have largely been overlooked, and their proportion of the building's overall carbon footprint will continue to rise as we're making more and more great progress on operational carbon. And that's really where Carboncure is focused, is helping construction decarbonize on the embodied CO2 emissions, which tend to be some of the more hard to abate emission reductions of buildings. So before I begin, I'd like to start off with a quick video that was made by our good friends Bill Gates that provides a bit more visuals and video of Carboncure and what exactly we're doing. So please enjoy.
The world is expected to add more than 2 trillion square feet of new building space by 2060. That's the equivalent of adding another New York City every month for the next 40 years. Many of these buildings will be made using cement, a massive emitter of greenhouse gases. But a company in Canada discovered an innovative way to reduce cement's carbon footprint.
The effects of climate change are going to happen. We're seeing it every day, but this is a solvable problem. Our industry can decarbonize. Cement is the glue, it's the active ingredient in making concrete, and is the product that we build modern society with.
People often ask, what is the difference between cement and concrete? Cement is really the chemistry behind concrete. A simple analogy would be if you're baking a cake, the flour would be the cement, and the cake would be the concrete, the finished product.
To make concrete, you dig up limestone from the ground, and then you run that through a kiln. Each pound of limestone that you put into this kiln, 1/2 goes up into the atmosphere as CO2. Carboncure is a technology company helping concrete producers transition into the new low-carbon economy. We developed a technology that bolts on to an existing concrete plant. We're starting with a greenhouse gas, a harmful waste product, and we're turning that into value. We add a small amount of CO2 to react with the chemistry from cement that allows you to create a higher strength concrete. Carbon utilization is not just some abstract idea. It's not just happening in the lab. It's happening in the real world.
The concrete industry has worked for years on sustainability, and so now we're looking for new technology. And Carboncure sequesters that CO2 into the concrete, locks it in forever.
Then you can actually lower the amount of cement in that concrete. It's really taken hold, and it's building real things that we can live in and drive on every single day, with overpasses and roads, airports, aquariums, or it could even be tech campuses. Carboncure is on a mission to reduce 500 megatons of CO2 emissions per year. That is the equivalent of taking 100 million cars off the road, or the equivalent of the CO2 reductions from 500 million acres of trees annually.
We're finding in the marketplace, both with our customers and internally, people are proud to work for someplace that is taking care of the environment.
I'm doing it for my family. I'm doing it for my daughter. There's a real human toll to climate change, but absolutely the solutions are there. Great. I was just thinking my daughter just turned 1 year old yesterday, so it's a good reinforcement, I know, for myself and many of others of you who are working on this space. There's a personal and certainly a societal element of working on climate change. So I hope that provided you some background on what we're doing and around embodied CO2 emissions and how important it is for us to be able to take urgent action to reduce these emissions. And I think this chart is something that Architecture 2030 put out that was a great visualization that shows over time the primary contribution to embodied CO2 emissions or overall emissions, I should say, is coming in those first 10, 12, 13 years from embodied CO2 emissions. So as we set targets to be able to meet our 1.5 degree climate emission targets and being only a decade away, is that really it's the embodied CO2 emissions and those reductions that are going to matter most. And then over time, of course, the operational emissions will continue to rise. So what are we doing going forward? As Bettina had mentioned, we're setting goals and we're reducing those CO2 emissions, and Architecture 2030 and Structural Engineering 2050 have set goals to completely eliminate the embodied CO2 emissions of construction. And that's going to be a stepwise approach year over year, as you can see, where we're going to be needing to make significant changes to reducing that embodied CO2. And that has to primarily be concrete and other materials as well, but concrete by far is the major contributor. So I don't know if many of you have gone through any weight loss programs, but it's pretty hard to lose weight, or in this case, hard to lose CO2 emissions if you're not measuring. And that's where there's an important role here to play for environmental product declarations, or EPDs. This is like a nutritional label for building materials, which allow designers the ability to actually look at the environmental impacts of materials and make procurement and specification decisions that are based on actual numbers that have been validated by third-party groups. It also fits within building certification schemes as well, but it's going to be a key tool for us to be able to drive out CO2 emissions. So a bit more about Carboncure, and this is one of our plants in my hometown in Victoria, British Columbia, where you can see that it's a simple retrofit where we work with concrete plants, in this case in Victoria, but HC&D and Island Ready Mix and Hawaiian Cement as well now, to use CO2 in their construction process. And we do it in a very simple retrofit way that allows them to consume CO2 that's sourced on the island. And that CO2 then is injected and mineralized into concrete to be able to provide both material performance benefits as well as environmental. And as you will have heard about before, why are we doing this? Well, we're doing it to reduce 500 megatons by 2030 annually. We're doing that to play our role in helping to decarbonize this industry and helping to make a better planet for our kids as they grow up. So how are we doing? We're still a long ways off. We've now cracked 450 plants that are using this technology, mostly throughout the United States, but are now expanding quickly. And as of yesterday, are now operating in 6 different continents. And this has been very, very thrilling to see the growth of a technology take hold. We've provided over 14 million cubic yards of concrete to a variety of different projects, just about anything you can think of, that have provided about 123,000 tons of CO2 saved. And all this is doing that in a way that's compliant with existing codes and standards. We were also recognized this year as the winner of the Carbon X Prize, which was a 5-year global competition to choose the most scalable CO2 utilization technology on the planet. There was 2,000 teams that initially entered this, and we were thrilled and last April to be announced as the winner of this prestigious recognition. The first X Prize was actually won by Richard Branson for commercial spaceflight. It was interesting this year as well to see how he had then taken that to the next level about actually realizing that vision. Also this year, we just signed the Climate Pledge. So not only are we helping others reduce their carbon footprint, but also looking inwardly. We're making a commitment to ourselves, Carboncure, being net zero by the year 2040. And this year, we're also quite excited to announce that in 2021 was the first year that we were completely carbon neutral, and doing that by reducing our emissions, buying renewable energy credits, and then anything else that was remaining, we purchased carbon removal credits. I just want to provide another short little video here before we wrap up on how actually the technology works, and just getting a bit more detail on looking inside the chemistry and inside the actual production process. So I'll play one more video and then have a few more slides and then pass it back to you, Bettina.
The good news is now there's an easy way to reduce embodied carbon in new buildings without making compromises. Here's how it works. Carboncure offers a concrete solution to reducing embodied carbon. Carboncure's technology works by injecting recycled carbon dioxide, CO2, into fresh concrete during mixing. Once injected, the CO2 undergoes a chemical reaction known as CO2 mineralization, where the CO2 converts into a nano-sized mineral. What was once CO2 is now eliminated, never to be re-released into the atmosphere. Mineralized CO2 improves the concrete's compressive strength, which then enables the reduction of cement content in mix designs without impacting strength or performance. Every cubic yard of concrete produced with Carboncure's technology saves an average of 25 pounds of CO2 emissions from entering the atmosphere and provides a 4 to 6% reduction to global warming potential. An average building built with CO2 mineralized concrete would save approximately 1.5 million pounds of embodied carbon, which is equivalent to the carbon absorbed by 888 acres of forest in a year. Carboncure is compatible with all materials commonly used to replace cement in concrete, including fly ash and steel slag. This allows designers and engineers to stack Carboncure among other carbon reduction strategies for maximum impact, supporting embodied carbon reduction goals and contributing to LEED points.
Thank you. All right, so what are we doing again? And I'm originally a chemist and had developed this technology initially. So as you saw, we're using CO2, which is what we're showing here on the left-hand screen. And it actually looks like snow. So I'd like to joke that in Hawaii, we're making it snow every day. That CO2 is in that snow form is added into concrete to form this permanent mineral. And as you can see in this, this image here of a scanning electron microscope of concrete, is it looks like a little sugar cube. Those sugar cubes are particularly important because they act as nucleation sites for the hydration reaction to occur and provide that increased compressive strength. And this really takes us to projects. So while this is happening at the chemical level, today we're here to talk about this Adler Street project, which is particularly exciting because it's also the highest building that has been made with Carboncure. It was supplied by HC&D, Ready Mix Concrete, a local supplier, and had resulted in 61.9 tons of CO2 reductions, which is about the equivalent of 76 acres of absorbing CO2 for a year. So we're absolutely thrilled to be part of this project, working with such fantastic partners and doing that in Hawaii, where so many of our innovations and first have occurred. And then we take these lessons and these new ideas and spread them around the world. So Hawaii is an especially important market for us, and one that we like to continue investing in. One of the more recent milestones as well was on DOT work. There was a lot of national press that occurred about the first use of Carboncure concrete on a state DOT project, and that was done here in Hawaii at the Kapolei interchange. In that case, the concrete was supplied by Island Ready Mix, and received a lot of attention by other DOTs, which has then opened the door for now many other DOTs across the country, and for that matter around the world, to be incorporating Carboncure into their carbon reduction strategy. So yet again, another first that occurred in Hawaii that's had ripples effect around the world. Another really exciting thing which started a lot of this is in combination or in collaboration with Elemental Accelerator. And we mentioned Aki earlier, who had connected me with Bettina, is we were able to also develop new innovative policy models, which drove the adoption, as we've seen in Hawaii today, of these low carbon concrete technologies in a very practical way, with no sort of a no-lose situation where Carboncure has then been able to use on both public and private projects. This policy model actually won a global award by the C40 Cities Group, where Mayor Caldwell was given this recognition in Oslo a couple of years ago for creating this policy model, which has then been adopted by states and cities around the world. So yet another first in creation that has happened in Hawaii that has had these impacts around the world. So we're so grateful to have this opportunity to talk about this project today, and we're sure that it will continue to have major implications. And this really turns to other projects, and public sector and private sector have a very important role to be, as Bettina had said, urgently looking for solutions to reduce the embodied CO2 of construction. And that can be done first and foremost by asking for data, asking for the numbers, and really making decisions around procurement and specifications accordingly. And then when possible, using your procurement powers to be able to make informed decisions on how you can reduce that embodied CO2 emissions. One project, as we've seen in Hawaii, can really have implications about accelerating the market transformation, not only across Hawaii, but really around the world. So we're really looking for those other partners where we can be working with to have similar type successes. And there's just as other references here, I've decided just to pull a few of these up. One of them that's receiving a lot of attention is the new Amazon headquarters is being built with Carboncure, as well as many other types of construction, from manufacturing to buildings, and of course, a lot of residential. It's been an absolute pleasure to be here today, to be talking with you all, and looking forward to hearing about the other panelists and what they have to say, and also answering the questions later on. Thank you very much.
Fantastic. Thank you very much, Rob. That's incredibly interesting. Congratulations is definitely in order. First of all, for, in Hawaii, first birthdays are a particularly big deal. So congrats to your first, to the first birthday of your daughter. Her and I share a birth date.
Oh, are you kidding me? No.
I'm a few years ahead, but yeah, very cool date. But also amazing to see the global recognition and awards that Carboncure is receiving. And lastly, to the audience, we're always quick to complain, and there's something to be incredibly proud of, because Hawaii is a leader, and we in this field here, and we set some firsts that we can be truly proud of. And thank you, Rob, for being so instrumental in all of this. I will hand the floor over to Alana to hear more about the Alder Street project. Alana, please.
Great, thank you so much, Bettina, and thanks for the introduction, Rob, and for the opportunity to work with your company on this exciting project. So I just wanted to, I'm just going to say a few words before I turn it over to Steve Tevis to introduce our project at Alder Street. But I just wanted to tell a little bit about the why and the history of why we got involved and wanted to use Carboncure at our Alder Street mixed-use project. About 5 years ago, our company set an internal goal that we needed to become a force of positive change in our affordable housing crisis. And so we committed internally that moving forward, we're going to produce one affordable housing rental or for sale unit for every market rate and luxury unit that we produce ground up. And so that led us to focusing first and foremost where we thought we could add the greatest value was in the low income tax credit 60% area median income rental sector of that, of our community's needs. And so that started this project. And then a couple years ago, working on a separate project, I had the opportunity to meet with Dr. Chip Fletcher at the University of Hawaii and sat through his presentation, about 2.5 hours of hearing. And these are all things that I intellectually knew. I've read articles, I understand what's happening in the world from a climate change perspective, but there was something about that day that had an incredible impact on me. I went home and I definitely held my kids. I felt, and I thought, you know, I know we've done a good job, but I know we can do better. We can do more, and we have to, and it's urgent. And so just started the path of researching and seeing how we can, what we can do as real estate developers, how we can drive positive change in the built environment. And so actually it was again, Dr. Chip Fletcher who suggested that I look into Carboncure. He shared some information about it and I started researching. And I'm really grateful to actually Elemental Accelerator. I reached out to them. Their vote of confidence and interest further pursued my research. And then, you know, really commend the state for doing the first project with Carboncure, because that, from my understanding, is what led to Island Ready Mix investing in the Carboncure technology. And Shorty Kuhn with Island Ready Mix was so generous with his time and talking it through with me and demystifying it. So then it came to thinking, how could we implement it? And we had a project that was getting ready to start construction, which is Alder Street, as discussed here. And I will say, talking to a lot to engineers and architects, I'm sure you would groan at your developer bringing up a new idea months before you're supposed to start construction, and as well as the contractor. But so I just want to say, I really just have to commend our whole construction and design team, because as much as there were risks, there were concerns, we're going to talk in depth about those. Everyone came together as a team and really tried to get to yes, instead of focus on the no and why we can't. And believe me, a couple times we almost came to no. But I think it was partially based on the type of project, which we'll talk about a little bit later. But it is, I think our comfort at moving forward was also about a long history of relationships and some trust that had been built between our various companies. And so all the panelists here, and including HC&D, I think really had to step up to the plate and be willing to take this jump together. So I'm really grateful to them first and foremost. I'll turn it over to Steve Tevis to introduce our project.
Oh, thank you, Alana.
Hold on 1 second. Let me just get our presentation up here.
Yeah, good morning. So I'll just briefly walk through the project just to give a description of the use and type, and kind of explain what this project is about. So again, my name is Steve Tevis. I'm the architect for the project. So Alder Street, it's an interesting project in terms that it's actually two separate projects combined together. Next, it's a judiciary facility with affordable housing, affordable rental housing on top. It's divided horizontally and vertically, which is challenging. As you can see kind of in this floor plan, this ground floor plan, P. Koi Street is on top. We have the residential side, and then Alder Street is on the bottom. And in the orange, we have the first floor of the judiciary, which is judiciary probation offices and a shelter for kids. So this is a great project, but it uses two completely different uses and combines them into one building. So layout, security, and privacy is important throughout the building. So the building is primarily a tunnel form structure tower, which you can kind of see in the middle. with PT slab, construction for the parking garage and adjoining office and shelter space. The building is set up where it feels as you drive around the block as two completely separate projects. They don't connect physically in any way aside from the structure itself. It's an R2 multifamily. We have 201 units of affordable rental at 60% AMI on top, with the judiciary shelter and offices below. It's about 200,000 square feet combined area. It's a little over 180 feet tall, 20-story building. And we have a 5-story parking garage, about 270 stalls, again, split between the judiciary on the ground floor, which is secured parking, and then the secured residential parking above. Next slide. This is the next second floor plan. You can see again in orange the judiciary spaces, and then you can start to see the residential on the second floor coming up with the tie-in to the PT parking garage. And then we have a typical tower plan. The building itself, the tower itself, the blue is 2 bedrooms, and we have 1 bedrooms and studios. Again, about 201 units. Next is just a few renderings of the project. On the left, the Alder Street Judiciary, that's the front entrance, you can see. And then on PE Quay side is completely separate residential entrance to their parking and their lobby and towers. And so that's the basics on the project. I think I'll turn it over to Steve Baldridge.
Thank you very much. Can you advance the slide, please? So as introduced to this idea here, and definitely wanting to reduce the carbon footprint of buildings, I found a lot of barriers to that. And I like Albert Einstein's quote of insanity, doing the same thing over and over again and expecting different results. So one train of thought I've seen or change in the industry is this fear of litigation, tight design fees, and all the code changes are actually leading to more conservative and material intensive designs. And if you go back to the Joe Paul Ronstadt buildings, were probably the most efficient buildings ever built in the islands. It's like 5-inch slabs, and actually very efficient from a layout standpoint as well. Not much common area, which it just adds to the amount of concrete there. The other barrier is that engineers are now specifying higher and higher strength concrete, often more than required. And in doing that, you need more cement to get that higher strength. So we're actually making things a bit worse. I don't think I'd want to be doing 3,000 PSI concrete in buildings, but if you look at some of the old buildings in Waikiki, you'll actually find some that have mostly 4,000 and some 3,000 PSI concrete. A lot of times now we're getting 5,000-6,000 PSI concrete, and sometimes 8,500 all the way up the building when it might only be needed in the lower floors. With the State Building Code Council, there's an awful lot of kind of vested interest pushing amendments into the code. And one that's being moving ahead right now and is actually, I think, embodied into the 2012 code, is to actually specify a prescriptive water cement ratio, a minimum, which means that you're going to have higher cement content than what might actually be required for strength, serviceability, or other needs. So there's, on the residential, like a 2-story house, you may have twice the amount of cement in that residential slab now because what's happening in the State Building Code. A lot of architects, reflecting on the fear of litigation, are requiring thicker concrete walls and slabs as well. I mean, some of this has to do with sound transmission or other things. I don't know how you get around that. Certainly fear of litigation. We all have that issue, especially the frivolous lawsuits that happen. But we're getting to thicker and thicker elements in the buildings, which means more concrete. And with every extra inch of concrete, wherever you put it, if that increases a wall thickness by 20%, well, that's 20% more cement in there. Coordination challenges on projects are also leading to thicker slabs, whether that's PEX plumbing, conduit, whatever. We really do try to coordinate as much as we can early in the project instead of just going thicker and thicker and thicker, and then still having challenges when you go to put all the stuff inside the slab. And then interestingly enough, having young designers actually talk the talk, but don't walk the walk. And what I say by that is the young engineer in our office one time was all excited about becoming a lead professional and talked about minimizing impact on the environment. And I saw a foundation they had designed that was twice as big as it needed to be. And I'm like, what are you doing? Well, I didn't have time to go back and refine it. And I'm like, well, you need to find the time because you can't just talk about it. You really got to spend the time and look at it. Next slide, please. So a famous structural engineer back in the 1900s would talk about strength is essential, but otherwise unimportant. So for us, our concern, of course, first and foremost is safety. And part of that is strength, but it's not the only thing that we have to consider when we start putting something new into the concrete mix. Fortunately, with tunnel form construction, the spans are actually very short and the walls are not heavily stressed, especially at this building height of 20 stories. So the concerns for strength, probably not as critical on this project as maybe something else we might look at in the future. Time is of the essence of construction. Every day you add to a floor cycle adds time to the amount of time of the overall project, and that adds cost. Sometimes it's trying to get the forms out quicker, and we want to make sure that adding something to the concrete doesn't slow down the curing time. And then, of course, for the folks out in the field actually doing the finishing, making sure that ease of finishing concrete was for them and not an issue. And then, of course, the quality of the finish, reduction of touch-up work. Next slide. I'm giving you all these quotes. This is actually a quote I had from my grandmother. She also say money doesn't grow on trees, but I say concrete doesn't grow on trees. And we need to be careful about not using too much of it. So first to start, reduce carbon content, essentially just by reducing the amount of concrete used on a project. Secondly, we look at what concrete strength we're using. Can it be reduced? Sometimes there's a diminishing return of higher strength concrete, and we don't need to use it. Do we cycle it back down 1,000 PSI or something? And then are there ways to reduce cement content in the mix design while maintaining required strength, durability, and other performance metrics? In some areas, like LA has very weak aggregate, they've actually been shipping in an Orca aggregate from Vancouver area to help get the strength without putting more cement into this. And this is where it'd be good to get involved with the cement or the concrete producers in the islands and taking a look at what they're doing to get the same strength with a little bit less cement. And that's where we come to the tool that we're talking about today, which is Carboncure, reducing the cement content while still getting the strength that we want. Next slide. And I think Robert said this as well. You've got to measure things and see where things are going. And we do that on all our projects. So we take a look at what's the cubic foot of concrete to square foot ratio. How much concrete is in a building? And actually, these numbers are interesting because 1.0 means that you have 12 inches of concrete for your average thickness of concrete throughout the building. So that's walls, floors, and everything else combined. Of course, rebar has its own carbon impact and post-tensioning, so you want to minimize those as well. An interesting question came up about tunnel form because there is so much concrete that you see in those buildings. The buildings in yellow under the concrete are all tunnel form buildings. And it's interesting to see that they're not actually that much different than a post-tension building. part of that is because a large percentage of the concrete usage in the building is actually in the horizontal work. And on a post-tension building with longer spans, you might have 7, 8 inches thick slabs in post-tensioning, whereas in a tunnel form, you can go 5 to 6 inches fairly easily. The walls aren't as thick. There's more walls, but they're just not as thick. The projects in green are all projects that our office has worked on. And one of the things we've tried to do over time is make sure that we're doing as efficient of a design as possible, because that brings value back, of course, to the developer client, but then also to the architect, and leaving money over in the budget for finishes and the other things that make a building just a lot more pleasant to live in. Next slide. And we do this throughout all of our offices. So we're checking different values for rebar. Next slide. Valid PT quantities versus the slab thickness. We've done some studies at looking at longer spans and to see if they make a difference, especially in podium parking structures. And actually what we found that there's a lot of concrete in the deep foundations that we need in Hawaii to get the capacities with the soils that we have. And we've actually found that sometimes going a longer span, it actually doesn't really add that much concrete to a project if you look at it close enough. Next slide. And this is a project actually that's fairly old, but what we found is using post-tensioning, for example, compared to just the reinforced concrete, you can do a very efficient design. And we received lead points for design efficiency. And back then, all I was thinking about was making it more efficient from a structural standpoint. But now you see the other impact is if we make it more efficient structurally, we're reducing the amount of concrete. And in the same time, we're reducing the amount of cement that's being used in the process, which is a big part of the program. Next slide. All right, I have to pass this off to ACK. Michael.
Hi, thanks, Steve. So I put together a little case study on the Alder Street mixed-use project. Again, my name is Michael Young with Albert C. Kobayashi Inc. We're the general contractor on the project. We've been working with Alana and her team for actually a couple of years, prior to the start of construction. But actually in July 2020, we were first introduced to Carboncure as a potential to be used on the project specifically. This was challenging because we, if you look at this slide, our start of construction was scheduled for October 1st, 2020. So basically a couple months before. Alana, came to us and said, hey, do you think Carboncure can be used? So, with any other new technology that's introduced, we do a lot of due diligence. So we started first by researching how it's been used in Hawaii. And we learned that it was successfully used at a project, highway paving out in Kapolei, supplied by Island Ready Mix, and it was actually built by Goodfellow. And so we did some due diligence and spoke with them about their experiences. We did some research with Carboncure, and we talked to some of the larger concrete suppliers. There's only a couple concrete suppliers in Hawaii. And so we spoke to all of them about the potential to use Carboncure. And at that point in September, we generated a list of concerns. Steve Aldridge just previously listed some of them, but we did make a list of concerns, and the timeline was tight because we had to make a quick decision. We're going to start construction in October. Next slide. So here are some of the concerns we came across, not only ACK, but in conjunction with our team members, our subcontractors, a concrete supplier, the engineers, the entire team. But like with any new technology, there is limited data. So with concrete, we want to make sure that the building is safe, the building is performing as designed, and with high-rise structures in particular, concrete and structure is a big important part of it. Unfortunately, there was limited data on Carboncure use in high-rise structures, no data in Hawaii, no data on tunnel form projects. I think we tried to research around the nation if Carboncure had been used. So we had a hard time finding, through our due diligence process, finding good data. Previously, like I mentioned, the only use in Hawaii was for slab on grade work, which is much lower risk than elevated, suspended slabs and walls. Along with that, the testing data for Carboncure injections was limited for the concrete we were looking for. We were looking for a 6,000 psi concrete mix. Most of the applications we found was 4,000 or 5,000, which is more common in buildings. But because it's a high-rise project and we had a very tight schedule, an aggressive schedule with the tunnel form construction, we actually had a 6,000 psi mix that needed to hit 2,500 psi strength in 18 hours, and that strength was required so we could dismantle the forms and move them up to the next floor to keep the cycle going. The 1 floor a week type of cycle you see on high-rise construction, particularly in Hawaii. So we had concerns there. Like with many other materials, there is limited supply. So at the time when we were researching this, there was only one supplier of carbon dioxide, Matheson, and so there were obviously concerns with supply chain. As we further researched, talking to the concrete suppliers, Carboncure injection does require certain specialized equipment, as was previously mentioned, and that availability of infrastructure and resources, wasn't all in place in Hawaii yet. Island Ready Mix had it, but they don't supply concrete on high-rise structures. So, that was a challenge. And obviously, the regular means and methods challenges of doing construction, cost, quality, is it going to affect production? Is it going to affect workability, shrinkage, crack, etc.? We had concerns with all of that, obviously, because the Hawaii concrete is different from concrete in other places. So without the data here locally, we had concerns. Next slide. So that sounds pretty pessimistic. And to be honest, maybe in September 2020, we had quite a challenging, pessimistic outlook, given the schedule we're up against, along with the factors that I just mentioned. So we had a big stakeholder meeting in November of 2020 with Alana and her team, HC&D, the concrete supplier, ACK, some other players. And we decided that in order to make this happen, we'd have to put in place a implementation plan. We rolled it out basically a little by little, and I'll describe what we did and what the results are. But the only way we felt that we would all be comfortable using Carboncure on this project was to use it over phases in increasing amounts, and I'll discuss that next. So we actually started right after that in December 2020 with concrete pours on the Otter Street mixed-use project. So we moved pretty quickly on this. Next slide. So we put together a specific implementation plan. As I think Rob mentioned, the intent of Carboncure is to inject the carbon dioxide and then to remove cement. But in order to do that, it needs to meet strength, it needs to meet quality, it needs to meet all the other, check the other boxes. So we determined that the high-risk areas, we would take a very conservative approach. So the auger cast piles, the foundation of the building, we didn't touch the specialized mix design. We just left them as they normally are installed in Hawaii. On the pile caps, we put in place we injected the Carboncure, but we didn't reduce any cement. At the slab on grade, we did a 3% reduction instead of the desired. The desired reduction, optimal reduction, is 5%. So at the pile caps, and then the slab on grade, we did 3%. In the tower, as we moved up the building, we started with no cement reduction. From floor 7 and on, we went to 3% reduction, and then from 13 and on, we started going to 5% reduction in certain areas, particularly at curbs, some low walls and other places. But we started increasing the cement reduction over the course of the project. So very phased approach, something you would probably see in a R&D type of project, but given the risk that we're up against, we felt that this was the best way to implement it to protect what was important, and keep the risks mitigated, as well as take this opportunity to really experiment with this new product. So we did have, along with that, some significant testing, which I'll cover by both base and HC&D throughout this process. Next slide. So this is a visual of our implementation plan. As I mentioned, the green would be the 3% reduction. The brown in the lower floors was just injection only. And then on the upper floors, we started to progress to a 5% reduction in some areas. And so you can see we did a phased approach. Next slide. This is our typical pour plan. I think the typical floor is about 9,500, 10,000 square feet. So we're talking about 3,000, 3,500 square foot pours. And tunnel form construction, as many of you may know, is driven by cycle, driven by speed. That's one of the big benefits of tunnel form, is the typical nature of the construction and the speed production you get out of it. So we have 3 pours of floor, and we needed to hit this cycle, as I mentioned, where we're stripping forms a couple of days later. So we needed to meet that strength within 18 hours. That was one of our biggest challenges. Go ahead, next slide. This is the parking. The parking was about 18,000 square foot plan, so we had 2 pours for that. Okay. So here's the results. Next slide. We we measured a lot of data throughout this project from a testing perspective. So the typical mix design, 6,000 PSI at 28 days. We typically, if you were to test that, it's designed a little conservatively, so you would see the 6,000 mix breaking at 6,000 to 7,000 PSI, somewhere upwards of 6,000, of course. So we actually took data for all the different products, and with injection only, with no cement reduction, we're actually getting breaks in 28-day breaks at 8,000 to 9,000 PSI. With injection and 3% cement reduction, we're actually getting in the 7,000 to 8,000 PSI range. And the optimal, which we realized, through the course of the construction, the optimal design is to inject the CO2 and reduce the cement by 5%. And we found through the course of this project that it actually achieved that. Hawaii Concrete can basically, 6,000 PSI can achieve it with a 5% reduction and a Carboncure injection. So this was an awesome conclusion we drew. It obviously took the course of the project and a lot of testing data to draw this conclusion, but really good feeling coming out of this project. We just topped off 2 weeks ago, and the data we're still seeing has been very optimistic in terms of reaching strength while reducing cement. Next slide. Cost. As with any new technology, there are always concerns about cost premiums. Everybody knows the benefits, but in the business community, of course, we have a responsibility regarding cost. So we evaluated this, and there are a lot of challenges here, like I mentioned, with supply chain and other factors. So we made an agreement actually between HC&D, our developer, and ourselves. We split the cost and a lot of the risk on this project to be able to implement Carboncure. So thank you to our partners. Longer term, we are still evaluating costs in terms of getting CO2 here, the cost of cement, how much you would save by reducing cement, with the premium for the equipment, and like I said, the CO2. So that's still an ongoing evaluation. But hopefully longer term, as Carboncure becomes more of a commonplace in the industry, hopefully that creates economies of scale and brings the cost premiums down. From a QA/QC and a production perspective, we didn't see any major premiums. We discovered that the concrete was performing quality-wise. Our guys in the field said they were hitting the same workability and productivity regarding the material with the Carboncure injection and cement reduction. So very good results from the Auto Street project. Next slide. From a schedule perspective, as I mentioned, this was always our biggest concern, our biggest risk was not impacting the schedule. And so what we ultimately decided to do to not impact schedule, not impact quality, but still implement Carboncure was this phased implementation plan. And it worked very well. Kudos to our team and our partners and stakeholders on the job, but we encountered no schedule impacts. So we're still on track for completing the project second quarter of next year. And like I mentioned, we topped off 2 weeks ago. So no schedule impacts from the Carboncure injections and implementation on this project. So lastly, in conclusion of kind of the case study of this Auto Street mixed-use project and a more general discussion about innovative technologies, particularly in Hawaii, there's always a lot of risk. We're a contractor. We're always in the business of trying to reduce and mitigate risk. So when new technology introduced 1 month before the start of construction, understandably is going to cause some concern by a lot of us. So I commend our team. I commend, starting with Alana at the forefront. To get this implemented and done was a big challenge, but it took a commitment by all the stakeholders. Steve, both Steves, HC&D, Carboncure. We all had to work together. We had a lot of discussions. We had a lot of communications, and we were very honest with each other about the concerns. I called Alana many times and I said, I have concerns about a lot of different things, and I'm not sure if this is going to happen, but she kept pushing through. She kept persisting and saying, we got to find a way. And we agreed to share liability risks. We agreed to share cost risks. And, I have to thank everybody in the community. We got a lot of help through the due diligence process from other engineers, from other contractors using this product, other suppliers. It's been great. And that's really the reason we were able to get this done. So thank you. Thank you to everyone in Hawaii and everyone else involved with Carboncure. That's all I have. Thank you.
I wish we were in person and could give our panelists a roaring round of applause. This was absolutely fascinating. It was it gives all of us something to aspire to. I applaud you, Alana. Your statement of being a force, of wanting to be a force of positive change in Hawaii is so admirable, and I applaud you. And you assembled a stellar team that followed your vision, and this is spectacular. So it's a pleasure of being here with you and now having this conversation. We are 15 minutes ahead of schedule, which allows us to do more of a dialogue and answer more questions. I have a whole slew of them, but I wonder whether we should go and jump into those that come from the audience first. So I will, I'm not sure whether everybody sees them, so what I will do is I will read them and we'll go from there. First question up here is, in attempting to achieve X dryness in 18 hours, what happens if heavy continuous rain occurs at that time? Oh, Michael, I think that is a question that is coming your way.
All right, can you repeat that one more time?
Well, I'm not even sure if I read it right. In attempting to achieve, I think, a certain dryness within 18 hours, what happens if heavy continuous rain occurs at that time, or during that time?
I think that creates a challenging situation. Weather in Hawaii, especially during the winter. This is a separate topic from Carboncure. I think whether or not there was Carboncure, obviously a lot of rain will have an impact on our schedule. So what we do as a contractor is, our schedule is built Monday through Friday, but oftentimes if we have a rain out day, we have rain out days built into our schedule, and we'll try to recover. So if that means that we have to cut our pour in half and pour the next half the next day, or pour it on the weekend, it does take a lot of flexibility. But ultimately, the goal on high-rise construction is to maintain a cycle and a schedule. So we do what we can to mitigate. But with an excessive amount of rain, or say a hurricane were to hit, then we would obviously have to stop construction, stop pouring.
Yeah, and this is outside of what Carboncure can help us with. Yeah. Thank you for your answer. Okay, next one, and I'm going in chronological order here. Okay, kudos to the team for addressing concrete's outsized contribution to climate change. The use of high volume fly ash concrete or substitution of other SCMs can reduce embodied carbon by 40% or more, compared with a maximum reduction of 6% cited for Carboncure. Is 4 to 6% enough to meaningfully move the needle on concrete?
I'll answer that one.
Yes, thank you.
There is no silver bullet. We need to be contributing as many, layering on as many solutions as we can. Certainly 6% is not the maximum. Some producers are achieving higher numbers. And we're also developing new technologies that will allow us to reduce a further 30% of the reductions by working with CO2 in aggregates and CO2 in treating and reusing the wastewater from concrete plants. So by no means are we finished our work. I think another important distinction here is that the CO2 emissions that Carboncure can offer are what are called carbon removal. And this is CO2 that can actually be used to reverse climate change by pulling CO2 out of the atmosphere, or which could be captured from machines or biology. So there is a different role that carbon removal can apply that also do contribute to the embodied CO2 emission reductions of buildings. But let's not start picking one solution over another. Let's put them all to work and achieve the deepest reductions that we can immediately with those that are both cost effective and don't impact the performance of the building.
And all of us can help you with that. I need to help you with that. Yes. Thank you, Rob. Andrea is asking, she says, fascinating. One thing Michael mentioned is the concern for the supply chain of CO2. How is CO2 captured and converted into the snow form? Is it something that could be manufactured locally? I think that is partially you, Rob.
Yeah. This is obviously an especially important question for Hawaii, which has a particular sensitivity to imports. And in this case, CO2 is actually captured as a waste byproduct from the Hawaii gas or syngas operations, which is on Oahu. And so that it is manufactured locally and captured as a waste product. I think in the future, there's opportunities to even look at other options as well of capturing CO2 if that supply of CO2 does come to an end. I think there's some other really interesting and exciting opportunities to capture it locally.
So you mentioned Hawaii gas just now, and Michael mentioned earlier that the CO2 used came from Matheson. Does that mean we now have two sources of CO2 locally?
I can't speak to that. I'm sorry, Bettina, but I don't know. Yeah.
Okay. Go ahead.
I can't necessarily speak to that either. So my statement was in reference to the due diligence process at the time when we first started looking at Carboncure. I'm not even sure if Hawaii Gas at that time was producing it. There's only one concrete supplier, Island Ready Mix, and one carbon dioxide supplier, Matheson. Yeah. Since then, I'd have to ask HC&D. I would guess that there's more options now, but at the time, yeah.
I'm sorry, I misunderstood the question. These companies like Matheson are distributors, and they all collect CO2 from that location. And there are others who are in the business of supplying that CO2. So Matheson, for instance, would be capturing CO2 as other companies like Airgas. It's the same CO2 that's used in the beer that you may have after the session to celebrate, or for refrigeration and chilling of food products.
Ooh, I'm not sure if that just helped.
No, it doesn't.
About what we're drinking in the beer is what goes into the concrete. But yeah, that answers it. Appreciate it. Thank you. There's one question here. Does Carboncure concrete affect how the building ages over time? And does Carboncure concrete also address the health impact of concrete on construction workers during the construction process itself? So I think there's a two-pronged question. How does Carboncure concrete age? And is there anything affecting health of workers in the process?
You wouldn't see a difference from any other concrete being provided to or being used in Hawaii. You know, it's not that fundamentally different that you would expect that to occur. It has a more efficient use of cement, but there's a wide range of cement loading in different concrete mixes. So you wouldn't expect that. And an interesting thing is that the CO2 is mineralized once it's added. So some of those videos would show that it's not a gaseous form anymore once it's put in contact with concrete. In fact, it's actually returned back into a stone in a nano format. So think of like limestone and calcium carbonate. So there's no harm whatsoever or no risk for the health of the workers on the construction site.
That's fantastic. Really, truly is. One question here. Is there any pushback from the cement suppliers by going the Carboncure route? What do you think about the long-term cement industry effects? It might be something Michael wants to jump into as well. He doesn't make eye contact, but I saw him nod.
I think the concerns of initially were shared by many parties. I wouldn't say it's necessarily only the concrete suppliers or the cement suppliers. I believe cement's not locally produced. It's shipped in. So I can't speak to the actual cement suppliers from the mainland and politically what their agenda may be. I can say that there was concern and pushback, not from a business or competitive perspective, but more just from quality and doing something new in Hawaii. So there was a lot of concerns from the local concrete suppliers. I don't know if that answered the question. Yeah, I cannot comment specific to the cement supplier though. But I think this will have long-term effects, definitely, both locally and nationally, both on cement and concrete. I think that this is trending upwards, especially with the positive response we had at the Alder Street mixed-use project.
No, Michael, that's answering it perfectly. I appreciate it. Thank you. Sorry, Rob, didn't mean to interrupt. Go ahead.
I was going to say that cement companies, like in any other industry, and those that are large emitters as well, are certainly looking for opportunities to decarbonize. They're feeling pressure from every single direction on trying to transition into the new low carbon economy. They also see it as a competitive advantage. So we work with a lot of cement companies on their concrete operations, and are even doing some work dating back to 2018, where we're even capturing CO2 from cement kilns so that they can be used downstream in their concrete operations. So certainly cement companies need to be part of the solution. We need everybody to be part of the solution here. And I feel like they're certainly trying everything possible at the moment to be able to help to reduce their carbon footprint, because it's a risk and an opportunity.
Yeah. Great, thank you. Where are the CO2 plants located? Somebody's asking, are there plans to build a plant here locally?
Yeah, it is local. It's the syngas plant with Hawaii Gas on Oahu, and they're I think it would be interesting also to look at direct air capture opportunities or capturing from other sources of CO2. But these are just some of the things in the future that might be available, but there's a local and abundant source of CO2 today.
Perfect. Two more questions that are here right now. Will the Hawaii-based strength test information be shared online so that other design teams may reference it in the future? Maybe that's an AIA question. We'll get back to this. Next one. If there are cracks in the concrete, could water infiltration result in the dissolving of the calcium carbonate, much like karst foundations? Steve, that might be a question for you.
Actually, I think Robert might be better suited to answer this one, but is this?
Yeah, so if you think about it, yes, some of the CO2 reductions occur from mineralizing CO2, but most of the CO2 reductions occur from using less cement. So that idea of dissolving the water into potentially dissolving calcium carbonate, I think would have a very negligible effect. Certainly, it wouldn't have any impact on the emission reductions of that concrete from cement that you didn't use, and the cement that's mineralized. I wouldn't expect that it would be dissolved in any sort of meaningful matter. I think you have much bigger issues, of course, if you start having cracks in your concrete and affecting pH, but that has nothing to do with Carboncure.
No, and that goes back to good architectural design and waterproofing, because no matter what, concrete, three things about concrete: it's gray, it's hard, and it cracks. So you just want to make sure you've got some waterproofing on there, and that's, if there is a crack, water's not going to come into the building, or for that matter, even into the parking structure.
Okay, we have one, thank you. We have one more question from the audience, and then I will take advantage of the privilege of being a moderator and ask some of my own questions. So last question here so far. Does anyone know if concrete mixers on outer islands are planning to implement the Carboncure add-on, and how much does it cost to add this piece to their operations? I think, Rob, that starts with you.
Yeah. So we're certainly having discussions. What's been fantastic is all of this private and public sector demand signals for low carbon concrete have created a lot of interest, and most concrete producers are now using this and offering it to the market, which is a very healthy competitive dynamic, and it's leading to a lot of CO2 reductions. So I expect that we'll continue to see that trend going forward. The other half of that question was, the cost. So Carboncure uses a model where we don't charge for the equipment, but there is a recurring monthly fee, and there's also a fee for consuming the CO2. Oddly enough, is that CO2 is actually a commodity that needs to be purchased, and despite all of the talk around global warming. So our job is to design technologies which provide the material benefits and the cost savings or production efficiencies, which then negate those costs and provide concrete producers with a win-win opportunity to provide low carbon concrete to the marketplace.
Okay, great. That's very helpful. One question very general for each one of you. Based on what you know now, and after the experiences on this very first vertical project here in Hawaii, what would you do differently on the next one? I know all of you have a comment. Yes, Alana, please. Yes.
Bring up the idea earlier. I think everyone would have appreciated that. And so we are in discussions on 2 projects already, and have been using the information we learned through Alder Street on how that can make us more comfortable. And I would say along with that, I said that we would discuss a little why this type of project made us more comfortable, and maybe why, at least on Kobayashi Group standpoint, wanted to push hard to try it, is that, this was our first rental project. And we will be the owner and operator of this, or others to follow me, for 75 years. And for that reason, I felt that it was the best chance to implement something new, because we wouldn't be in a situation where we're selling condos and then dealing with the unknowns of litigation and the fears. So I would tell you honestly, if this was the first for sale project, I would not have felt comfortable pushing forward. And so I think that's why, I really, commend the whole team, but really also pushed to say, this is our chance to do something really meaningful. And we won't have another chance until the next rental project to be the first time, in my mind, from a developer's perspective. So that was one major factor in our decision making. But I'll turn it over to others to chime in.
That is a huge point, and I appreciate your making it. Would you use it moving forward? Would you consider it for a for sale project yet, or is it a little bit too early to ask?
For me, but of course, again, I think as I said time and time, it's a team approach. Everyone has to feel comfortable. It depends on the type of project and everything. But I would say I am very dedicated to trying to implement this technology in future projects, including for sale condos. I do believe that what we've learned is that it doesn't really operate any differently. And as long as we can make it work in our schedule and all the other elements, it makes sense. But again, I think even more so, this is talking about what Steve Baldridge brought up at the beginning, which is we have to first start with, from the beginning, how can we all work together and set a goal, a sustainability goals that include how can we minimize structure safely, right? And so start from the beginning on all facets of this decision making. But definitely, I'm comfortable. But you know, others in this room are involved in our future projects, so and some of our future projects. So, you know, but I believe everyone feels much more comfortable now.
Bettina, I'd like to add to that too. We were very fortunate to have an MIT grad as our contractor who methodically set forth this program of a staged usage so that we were not really all in case something kind of went sideways. So there was a lot of lessons learned from the project. So you take those lessons to the next one, maybe ratchet things down a little bit and improve with each project. So, I mean, that very helpful the way it was done. So I commend you, Mike.
Yeah, I'll chime in. I agree on that front too. And I remember calling Christy Gamble with Carboncure and saying to her, hey, you know, I think we're getting traction here, but there's this desire to take the stepped approach. And she did share that that's not uncommon first to a market, and that really the meaningful thing was that we would get there, and that once there was a building, and then more and more people would, and designers and developers and contractors would feel more comfortable. So it was really about doing it the first time and doing it carefully. So again, I agree. I'm really grateful to Mike Young and his team for all the effort and for being conservative.
Great, thank you. Steve, anything from the architect's perspective that you would want to add here?
No, in terms of design and architecture, I think it has a lot to do with construction timing. You know, particularly in this one, it was a tunnel form, but if you're doing it in other projects, the time it takes for it to reach strength and so forth, that would come into effect, and depending on the size of the building as well. So architecturally, you know, it's something good to decide on early on. So far, you know, in terms of finishes, there's no, you know, we don't have any issues with that. There's no limitations. So design-wise, architecturally, you know, it's great as long as we get, you know, as we were talking about, the team and everybody decides early on is best, and we can kind of plan for it and help with the decision on which kind of structural system to go with. But otherwise, no problems.
That's awesome. That's terrific to hear. Thank you. Michael, I can't jump over you. What would you do differently on the next one?
I guess I echo what everyone else says, which is, you know, when you work with new technologies, innovative methods, obviously time is a big factor. The ability to get everybody comfortable. We all come from different backgrounds. We have different agendas. We're all working towards the same goal, but it is challenging. You know, it requires a lot of communication, a lot of trust. So, you know, the challenges with time, both during the construction process and the due diligence period up front, were the biggest concern. So as I mentioned, we addressed that through a phased implementation process. I think if we had more time, we might have reached some of those conclusions. We might have had more testing data, more information, and we would have been more aggressive with our rollout of it. But I'm still, you know, very proud of our team's effort and where we are today.
And as you should, as all of you should. I do have another question. really asking you to project forward. You are a group of rock stars, and you're showing the rest of us here how it's done. So as agents of change, what do you think the next step will look like? No, this is really big question, but anybody want to go there? Anything that hasn't been tried, but that you, from your standpoint, see coming? What's in the future? Maybe Rob, you need to unstick us.
Yeah, well, my job is to think about the future all the time and make that a reality. You know, what do I think are the big things that are moving right now that could impact? Yeah, I think a lot about public policy. I think some of these policy innovations that were also created in Hawaii are already being discussed now at a federal level. We're also hearing those same policy models being discussed and adopted in other parts of the world, in Southeast Asia, for instance, and Australia and Europe. There's a lot of interest right now in using government procurement to drive the climate agenda and tying it to things like infrastructure bills. It just makes a lot of sense, as if you can use that tool as a way of accelerating your decarbonization agenda. I think carbon markets are another thing that are really key. So carbon removal credits. So there's a lot of reforms that are going on to create very high quality credits that actually reverse climate change. So that's a really exciting area. People like Mark Carney, another proud Canadian, I'm happy to say, is leading a lot of this charge at COP26 coming up. You know, I think what gives me most hope, and what this company is based out of Nova Scotia, and in some ways it's actually a lot like Hawaii, is these communities that are coming together and actually making this a priority. And these sort of, I find this is the most fertile place for innovation to occur. It's not necessarily in the big cities and sort of big population urban centers. It's where things can really happen quickly because they have that connectivity that's already in place within these communities to make these kinds of things happen. I also really need to say, like, Elemental Accelerator was instrumental. Like, if we hadn't met them, this conversation would not be having. We would not be having this conversation. So, and they continue to be a fantastic inspiration for us as a company.
Yeah, they are for all of us. That's a great answer, Rob. Anybody else? Yes, Steve, please.
So from a structural standpoint, some things that are happening in the industry, there's higher strength rebars now finally making it into the code. And that has helped reduce the size of foundation rafts or the size of columns or shear walls. So that's a good thing that's happening, finally just making it into the code. There are some new forming systems that have come out that reduce the amount of concrete for a similar span. The one thing we're fighting, and you talk about approvals from government authorities, we're always fighting a height limitation. And some people have asked me about stuff like bubblecrete and different concrete methods. And it's like, it's very unfortunate because you can't go to a more efficient structure, which is deeper, because you're fighting a height limitation. So it's kind of a shame. We also worked on an affordable project that had a very inefficient floor layout. I think they were probably at like 60% or something. And the architect actually pushed to have the layout changed, but it was the government authority said, no, we want this look. So I think the industry, architects and engineers, need to somehow start talking to the politicians about our land use ordinances and some of the other things that we all fight day in and day out. You know, some of it dates back to the 60s and it doesn't really make sense anymore.
Yeah.
Yeah, absolutely. Anybody else? Steve, anything? Or
you know, one thing I'd like to say that I think is interesting about this project and the future and innovation, it doesn't always have to be on a very expensive or luxury or you know, very fancy building. This is an affordable rental housing. And even in a project like this, you can still create innovation and use new tools, new technology, even on projects like this, which are typically, I think, maybe thought of as, okay, let's stick to the safest, most efficient way to do something. It's affordable housing, but to be able to create a project like this and use this new technology, it can be done in any project. So something interesting to think about.
No, that's an awesome comment. And as a fellow architect, I wholeheartedly agree with that. Yes, thank you. I am getting signs here to wrap things up. We are 2 minutes away from the end of this session. And what I would like to do is truly, truly express my appreciation for this spectacular panel. Thank you again for your innovation, your leadership, and your vision. And you're showing us what we can do in our industry to make a meaningful change. So on behalf of the AIA and the rest of the world, thank you. I think I have to, sorry, I have this ad-libbing problem. Okay, I have to express a huge mahalo to our sponsors. I found my line, sorry. Just because innovation distracted me here should not take away from the fact that this session would not happen if it wasn't for our sponsors. Thank you for bringing up this slide. Please consider these companies here. Thank you truly for sponsoring us and making conversations like this one here important or possible, because they are important. I think this is it. I hope you enjoyed this. I'm supposed to now tell you that you just listened to the Carboncure presentation. Whew, I hope that none of you needed that information. And also, I am Bettina Maynard. Okay, and we will see you next time. Those of you that are sticking around for the closing keynote will see me again. Thank you all, and aloha.